Hi dear students, welcome to the new session. So, last class we discussed about motion, isn't it? Who can tell me what is meant by motion? Yes, when an object changes its position with time, then we can call it as what? Motion, isn't it? Yes, when a position of the object changes with time, then we can call it as what? Motion. And when we look around us, as I already told you, we can observe different types of movements. You know that bird flying, then the car is moving, then the leaves are just falling from the tree, and the people are walking, the clock is moving, the hands of the clock is moving. So different types of movements we are observing around us. And you are going to study about five, motion or five movement in this chapter. Five types of motion. Who can tell me what are they? Translatory motion, rotational motion, periodic motion, oscillatory motion, and vibratory motion. So the last class we discussed about two types of motion. What are they? Translatory and rotational. Who can tell me what is translatory motion? Yes, what happened? The whole body moves, isn't it? The position of the whole body changes and it repeats in fixed interval also. And two types of translatory motion you had already seen, rectilinear motion, and that's a straight line, and circular motion. Clear? Next we discussed about the rotational motion. So that motion, an axis is needed. Around that axis only the object moves, isn't it? So today we are going to discuss about the third type of motion. What is it? Yes, it is periodic motion. It is periodic motion. Hope you are familiar with the term periods, isn't it? You know, when you were in school that time, every day we had how many periods? 8 periods. And you had a timetable also, and that repeats. Now also you have timetable to watch the video classes also. That means every day it repeats, isn't it? Next Monday also same timetable. Tuesday you have one timetable. Next Tuesday also you have the same timetable. That means it itself repeats, isn't it? When it repeats only, we can call it as what? A particular time interval period is there. So Monday one period, next Monday it changes, then we cannot call it as what period. So what is actually period? It repeats, then only we can call it as. So what is meant by periodic motion? When the motion repeats itself in fixed time interval. When the motion repeats itself, you know that when we think about the timetable, Monday you have one timetable, next Monday again it repeats. Am I right? Tuesday's timetable, next Tuesday definitely it repeats. In the case of motion, when motion repeats itself in fixed time interval, when a motion repeats itself in fixed time interval, we can call such motion as what? Periodic motion. When a motion repeats itself in fixed time interval, we can call such motion as what? Such motion as periodic motion. When I say an example, you will understand it better. You know the rotation of the earth. How many hours does the earth takes to complete one rotation? Absolutely right. It is 24 hours. So after the day, isn't it? 24 hours, next day begins. It doesn't change at all. Every day it is the same. Every day we have how many hours? 24 hours. One day 24 hours, next day 30. Does it happen like that? No. So every day that is repeating. Such a motion that is known as what? Rotational motion is an example, or the rotation of the earth is an example of periodic motion. Not only that, revolution of the earth. How many days does the earth takes to complete one circle around the sun? That is actually revolution, isn't it? How many days it takes? 365 days and 6 hours. Okay. So that is also an example of periodic motion. After completing 365 days and 6 hours, then we can say next year begins. January, next year begins. Correct that day. And of course, leap year exemption is there. That day we have 366 days, isn't it? 366 days. All other years we have 365 days and 6 hours. Clear? So this rotation and revolution of the earth, they come under periodic motion. Why? Because it repeats itself in fixed time interval. Rotation 24 hours, next day begins. Again earth is doing it. Next again earth is doing it. So no change at all. Another example I should show you about the clock. Periodic motion is suitable example. It is the clock. You all have seen the clock or the watch, and they show also which type of motion, periodic motion. That means you know that in every clock or the watch or the timepiece you have 12 hours. This is 12-hour clock only. So the hour hand will take how many hours to complete one circle? 12 hours. And the minute hand takes how many minutes? 60 minutes to complete one circle. Okay, our hand take 12 hours to complete one circle, and the minute hand it takes how many minutes? 60 minutes to complete one circle. So now I will show you a timepiece, then you will understand it better. Clear? Okay, you could see 3 needles are there mainly. The right needle that is always moving, it is the second hand, isn't it? It shows the seconds. See, this one, the small one, it is the smallest one, it is the hour hand. Smallest one, it is the hour hand, and the largest one, it is the minute hand. This is the minute hand, this is the hour hand, and this is the second hand. Clear? Okay. So do you know that the second hand, it takes 60 seconds to complete one circle. How many seconds? 60 seconds to complete one circle. Clear? The red, okay, hope you see that red. It completes 60 seconds to, it takes 60 seconds to complete one circle. And this is the minute hand. The longer one, black color, it is the minute hand. It takes 60 minutes to complete one circle. And the smallest one, it is the hour hand. Smallest one is the hour hand. It completes one circle in how many hours? 12 hours. Okay, it starts from here, as you all know. Then 1, 2, slowly 12 hours it takes to complete one circle. So this is also an example of which motion? Periodic motion. Clear? Okay. The motion that itself repeats in fixed time interval, we can call it as what? Periodic motion. An example, hour hand, minute hand, second hand of the clock, rotation and revolution of the earth. These are examples of periodic motion. Now we can move on to the fourth type of motion. What is that? Oscillatory motion. Another oscillatory motion. What is meant by its oscillatory motion? To and fro motion, that is known as what? Oscillatory motion. I will show you an example. Just observe this. See, hope this is clear. Yes, so just when I hope this motion is clear. This motion is known as what? Oscillatory motion, to and fro. See, the to and fro motion, it is known as the oscillatory motion. When we observe, when I blow it, see how it moves? To and fro. See, this is a type of periodic motion also. We can call this oscillatory motion. We can call this oscillatory motion as what? Periodic motion. Hope it is clear. Yes, yes. So the pendulum of the clock is an example. Have you seen the pendulum of the clock? It's also an example of what? Which motion? Oscillatory motion. That is to and fro motion. Likewise, an object moves. For example, if the object is there, yes, it moves. A, we can call BC. Then what happened first? It moves to, then different manner it moves, and opposite also same manner. Likewise, it is moving. The pendulum of the clock, you have seen here. What will happen? Pendulum of the clock, like A, B, then C, C, then B, then A, B, C, C, B, A. Likewise, those who have it at home, you can observe how the pendulum of the clock moves. Hope it is clear how this to and fro motion, it is known as the oscillatory motion. What is oscillatory motion? To and fro motion is known as the oscillatory motion. Just observe this once again. See, beforehand this object is at rest. When I blow air only, when I blow it only, what happened? Definitely, yes, it starts to move. That is to and fro motion. It is known as what? Oscillatory motion. Clear? Yes. So a periodic motion, it can be periodic motion also. Now we can move on to the last type of motion, that is the vibratory motion. Vibratory motion. What is meant by this vibratory? Have you heard about vibration? You know, those who have seen use a guitar, veena and all know, when we just play the string, isn't it? Vibration can be seen. Yes. Just observe. Clear the sound. See, the sound persists. That is vibratory motion. Clear? See that vibration? Could you hear that? Okay, yes. So, this is another example of what vibratory motion, tuning fork, vibratory motion. See, very simple. You can check it at home also. Clear? So, this is the musical, when we play the string of the musical instrument, what happens? You should know that the string vibrates. That sound only we are hearing, isn't it? When you use the guitar, sitar, and you know, veena and all, no, by using the fingers we are playing it, isn't it? That time the beautiful, you know, melodious sound we can hear. That is the example of what? Vibratory motion. Soothing sound, isn't it? Guitar, very beautiful, isn't it? Veena and all, sitar and all, very beautiful because the vibration of the string. We're just using the fingers or some other small, you know, thing they are using for playing that so beautifully. That's it, because of the strings are there. Vibratory motion, vibration. Hope you have seen it clearly. So now you know about different types of motion. Now today we have discussed about periodic motion, then oscillatory motion and vibratory motion. Periodic motion, the motion that repeats itself in fixed time interval. Such motion is known as what? Periodic motion. Example, rotation and revolution of the earth. Then the movement of the hands of the clock, minute hand, hour hand and second hand, that you had already seen. Next we discussed about which motion? Oscillatory motion, to and fro motion. Beforehand the object is at rest. And what happened? It moves to and fro. That is that motion. Such a motion is known as what? Oscillatory motion. You have seen the example. Pendulum of the clock is a typical example of oscillatory motion. And next one, it is the vibratory motion. When you play the string of the, you know, in musical instruments like sitar, guitar, veena and all, what happen? The soothing sound can be heard. That's a vibration. And you had already seen the tuning, another type of vibration also. So these are the different types of motions. Clear? What are they? Translatory, rotational, periodic, oscillatory and vibratory. And you could understand one more thing. A single object can show different types of movement. Another thing. Single object can show different types of movement. For example, the car. You know, you have observed, I think, the wheel of the car. And how does the wheel of the car move? Does it move in a straight line? No. Yes, isn't it? In a circular Man, rotational motion. Wheel of the car, it is in which motion? Rotational motion. But what about how does the car moves? It is in a rectilinear motion, isn't it? Yes, even though the wheel of the car is moving in rotational motion, when how does the car moves? Does it moves in the rotational motion? No, it moves in what? It moves in a straight line or rectilinear motion or curvilinear. If curves are there, curvilinear motion. Clear? Yes. So first example, movement of the car. Tire is moving in the rotational, we can call circular motion, but the car is moving in what motion? Rectilinear motion. Another example, sewing machine. Sewing machine, stitching machine. Okay, that the wheels, as I told you about the car, in a rotational motion only, is in circular motion. And what about the needle? Straight line, isn't it? Yes, up and down motion. Another motion. Wheel is moving in the circular motion, but the needle is moving what? Up and down. So these are two examples. Then movement of the cycle, movement of the bus. So many examples we can say. A single object is showing different types of motion, and different types of motions can be exhibited in single object. And single object can show different types of motion. For example, periodic motion is example. Rotation of the earth, and it comes under rotational motion, it comes under circular motion. So single object can show different types of motion, and single object can exhibit different types of motions also. Example of is a machine. So car is also a machine. It's a complex machine. You studied the last year. Complex and simple machine. Hope you remember it. Yes, okay, it's complex machine. So different parts are there joined together. Simple machines are joined together to form a single object. So here also different objects are showing different types of motion. So with this we come to the end of this chapter. As I used to say every time, read the textbook thoroughly. Try to fill the blanks, and I will upload the notes as early as possible. Study well, dear children. Don't waste your time. Okay. So children, you can watch a video showing different types of movement. Then you will understand the concept very clear. I hope it is understood. But still, if anyone is having any doubt, when you watch that video, you will understand it better. Okay children. Until we meet in the next class, it's bye from me. Take care. As I used to say earlier, read the textbook thoroughly, do the activities. I will upload the notes as early as possible. So, be safe. Bye.
Types of motion. You may have observed the motion of a vehicle on a straight road, march past of soldiers in parade, or the falling of a stone. What kind of motion is this? In all these examples, we see that the objects move along a straight line. This type of motion is called rectilinear motion. Here's an activity. Take a stone, tie a thread to it, and whirl it with your hand. Observe the motion of the stone. We see that the stone moves along a circular path. In this motion, the distance of the stone from your hand remains the same, right? This type of motion is called circular motion. The electric fan or the clock by themselves is not moving from one place to another. But the blades of the fan rotate, and so do the hands of a clock. If we mark a point anywhere on the blades of a fan or on the hands of a clock, the distance of this point from the center of the fan or the clock will remain the same as they rotate. In some cases, an object repeats its motion after some time. This type of motion is called periodic motion. Take the stone tied with a string and hang it up. Now, hold the string in your hand and let the stone hang from it. Pull the stone to one side with the other hand and let it go. This is a pendulum, something that will help us understand about periodic motion. Now, the motion of a pendulum, motion of a child on a swing, strings of a guitar are all examples of periodic motion where an object repeats its motion after a fixed interval of time.